The origin of tornado sirens. Tornado sirens have their roots in the early 20th century. Originally, many of these sirens were not built for weather emergencies at all. They were designed as air raid or civil defense sirens during World War II and the early Cold War. Communities later realized that these loud, omnidirectional devices could be repurposed to warn residents of severe weather. By the 1950s and 60s, particularly after devastating events like the 1953 Flint, Michigan tornado and the 1965 Palm Sunday outbreak, towns across the U.S. began installing them specifically for tornado alerts. At that time, there were no smartphones, no TV weather crawls, and few homes had weather radios. A powerful siren mounted on a pole in the center of town was often the only warning system available. This historical shift marked the beginning of sirens as a frontline defense against tornado disasters. Types of tornado sirens. There are two primary types of sirens still used today: mechanical sirens and electronic sirens. Mechanical sirens. These are the classic air raid style sirens. They produce sound by spinning a rotor inside a stator, forcing air through slotted openings. As the rotor spins faster, the pitch rises, creating the iconic wailing tone. They are incredibly loud, often reaching 120 to 130 decibels at the source, and can carry the sound for several miles. Mechanical sirens are very reliable and can operate in a wide range of conditions, but they can usually only play one or two tones. Electronic sirens. These are modern systems that use loudspeakers and amplifiers instead of mechanical rotors. Electronic sirens can play multiple tones, pre-recorded voice messages, and even instructions like "Seek shelter now." They can also be remotely monitored to ensure they are working correctly. However, they rely on complex electronics and a power supply, which means they may be more vulnerable to power failures or lightning strikes. Many communities use a combination of both types, replacing older mechanical sirens as funding allows, but mechanical models remain common due to their durability. How tornado sirens are activated. Tornado sirens are not activated automatically by the sirens themselves. They are triggered by emergency managers or local authorities. Here's how the process usually works. The National Weather Service, NWS, monitors radar and weather conditions. If a tornado is detected on radar or confirmed by trained spotters, the NWS issues a tornado warning. That warning is received by a county's emergency management agency or local dispatch center. An official, often through specialized software or radio controls, remotely activates the sirens across the county or city. In some areas, activation can be done via radio signal, dedicated landlines, or even secure internet connections. The key idea is that sirens are meant for outdoor warnings only, not for waking people up in their homes at night. That's why meteorologists recommend having NOAA weather radios or phone alerts in addition to relying on sirens. Siren coverage and sound range. One of the most misunderstood aspects of tornado sirens is their effective range. Sirens are designed to warn people who are outdoors, not to penetrate walls or wake people up from deep sleep. A typical mechanical siren can be heard about 1 to 2 miles away under ideal conditions. Large electronic models may reach 3 to 5 miles, but distance reduces volume quickly. Factors like wind direction, humidity, background noise, traffic factories, and even terrain can all affect how far the sound travels. This means that in a large metropolitan area, dozens or even hundreds of sirens are often needed to ensure blanket coverage. Rural counties may only have a few sirens placed in towns, leaving residents outside city limits to rely on other alert systems. Tones and signals used in tornado warnings. Tornado sirens usually use one of two main sound patterns. Steady tone, a continuous, rising or steady wail that alerts people to take immediate shelter. Alternating or wailing tone. The pitch cycles up and down, often associated with more urgent emergencies such as a confirmed tornado. In some communities, electronic sirens may use different tones for different hazards. For example, one for tornadoes, another for chemical spills, and another for civil defense. Voice-capable systems may even announce messages like "Tornado warning in effect," "Seek shelter immediately," However, because tones and patterns vary between communities, local education campaigns are crucial. Residents need to know what their area's sirens mean and how to respond. Power sources and backup systems. Tornado sirens must be able to operate even during severe weather that causes power outages. Most systems are connected to the electrical grid for normal operation, but also include backup batteries or diesel generators. These backups typically allow sirens to function for at least a few activation cycles, even if the main power fails. For mechanical sirens, the electric motor drives the rotor, while electronic sirens need both power for amplifiers and for their control electronics. In some rural areas, sirens are even hooked up to local emergency facilities like fire stations to ensure they can still be activated manually if automated systems fail. Routine testing of sirens. Regular testing is a crucial part of keeping sirens reliable. Most U.S. communities conduct weekly or monthly siren tests, often at noon on a set day, when the weather is clear. Testing serves several purposes. Ensures the siren motor or amplifiers are functioning. Verifies that the communication link between emergency management and the siren is working. Familiarizes the public with what the siren sounds like. In many areas, if severe weather is expected, the test is postponed to avoid confusion. Routine testing and maintenance help detect issues like dead batteries, corroded wiring, or speaker malfunctions before an actual emergency. Limitations of tornado sirens. Despite their life-saving role, sirens have significant limitations. First, they are not designed for indoor warnings. With air conditioning, televisions, and even thunderstorms making noise, many people cannot hear sirens from inside their homes. Second, there is the problem of warning fatigue. If sirens are activated too often, especially for storms that do not produce tornadoes, people may start to ignore them. This leads to delayed reactions when a real threat occurs. Third, modern severe weather can occur at night or during power outages, times when people are least likely to hear outdoor sirens. That's why meteorologists strongly encourage using multiple layers of alerts, such as phone notifications, NOAA weather radios, and TV or radio broadcasts, in addition to sirens. Advances in modern siren technology. Today's electronic sirens offer several improvements over older models. Some systems use solar panels to maintain battery charge, reducing dependence on the power grid. Many can be activated from anywhere using secure internet connections or satellite links, and some integrate directly with automated weather warning software. Voice messaging capability is one of the biggest advances. Instead of just a tone, sirens can now broadcast live or recorded instructions, telling people exactly what type of hazard is approaching and where to go for safety. Maintenance is also easier because modern sirens often have remote health monitoring, allowing technicians to know if a siren is malfunctioning before the next test or emergency. The future of tornado warning systems. As technology advances, communities are moving toward integrated warning networks. Sirens remain an important tool, especially for outdoor venues like parks, stadiums, or school fields, but they are increasingly supplemented by other tools. For example, wireless emergency alerts (WEA) now push tornado warnings directly to smartphones. Smart home devices can issue alerts via speakers and lights. Local television and radio still provide context and live tracking. Some communities are experimenting with geo-targeted siren activation, so only the sirens in the immediate path of a tornado are activated, reducing unnecessary alarms in surrounding areas. This kind of precision helps reduce warning fatigue and makes people more likely to respond quickly when they hear a siren.